Hello everyone, this is Basement Builds and today I will be showing you how I built this robot hand. A few months ago, I decided to build a robot hand because I thought it would be a fun, quick, and easy project. The goal with this was to make a cheap robot hand with individually controlled fingers and a rotating wrist. I set a budget of $400, which meant I had to design and build pretty much the whole thing from scratch. I also set a goal of making the hand weigh under 500 grams, as in my research I found that that's the weight of an average adult human hand, and around what many modern prosthetic hands weigh. I also initially decided this robot should be fast, strong, durable, modular, waterproof, quiet, and force sensitive, but after the first "it's over" moment, those requirements all got replaced with "looks like a human hand" and "should work sometimes." On the mechanical side, I started off with the fingers. Each finger is contracted by a motor pulling on some fishing line and is retracted with some elastic string. Initially, I tested some designs using Kevlar or TPU as joints, but I found these to be too stiff. I might revisit these designs in the future, but for now I decided on this design, which uses 3 digits connected at the joints with 1 mm extruded chromium alloyed steel rods. The thumb was designed to be opposable, which means it closes like the other fingers, but can also rotate and close across the palm. The folding is directly driven by the worm gear motor, as you can see here, and the motor for the thumb digits is inside this space. I'm not an idiot, so I made sure to not permanently close the hand or forearm so I could fix stuff later on. The top of the palm comes off and is bolted in with a couple M3 bolts into some embedded threaded inserts. The top of the palm and the tips of the fingers are all covered with some silicone tape to increase the grip. Down here we have the wrist joint, which rotates around this piece of metal pipe, as you can see. The fishing line for the fingers goes through the middle of the pipe, and the wires are guided through the edge of the pipe. I spent about a week trying to bend this paperclip into the correct shape for this button, which, as you can see, meshes with this gear to lock or unlock the rotating of the wrist. Moving over to the forearm, we have 4 motors attached to winches, which pull on one of the fishing lines guided through here, each controlling a finger. Everything here was designed in Onshape and 3D printed on my Creality Ender 3v3 SE. Everything was printed in PLA plastic except the forearm shell, which was printed in PETG. To control the hand, I used the ESP32 microcontroller, which is a board that can read in sensor values and output signals based on code that you program and upload to the board. This was my first time using an ESP32 instead of an Arduino, and I've been pleasantly surprised. It's cheaper, smaller, has more pins, has more PWM and input resolution, and a bunch of extra features. The only concern is that it only supports 3.3 volt logic, but that worked fine for this project. To control the motors, I used 3 DRV8833 motor controllers, which worked pretty well. They're small, but can supply 1 amp and control 2 motors at once. Each motor also has a potentiometer connected to it, which determines the angle of the motor, which we can use to know if the finger is open or closed. This is all powered by a 7.4 volt rechargeable lithium battery. The board is also powered through the battery through this 5 volt regulator. I'm not entirely sure what these capacitors are for, but they were in the regulator schematic, and I'm a mechanical major, so I won't ask questions. These 2 switches are to disconnect some of the motors from power. When I upload code, some of the motors move erratically for some reason, but I was tired at this point, and adding a switch was easier than debugging. Finally, we have these screw terminals, which connect to the sensors from the glove. The hand can be used with this glove, which controls each finger individually, or with this pressure sensor, which rotates through different pre-programmed grips every time you flex. Here we have it set up to switch between open, closed, and this sort of pinch and grip. Building the glove and forearm sensors were a whole other nightmare, which I won't get into, but I may make a separate video on sometime. Unfortunately, all these components need to be connected, which caused me quite a few headaches. I had to solder about 150 connections, which was very hard in such a small space, even with these helping hands, and the connections kept breaking at the folding portion of the thumb. But I eventually figured it out and only destroyed 1 board, 2 pots, 2 motor controllers, and this part of my desk. The last thing to do is write the code that controls the robot. On the face of it, this should have been the easiest part of the project, because all I had to do is tell the robot what I want it to do. Unfortunately, this is the point where the whole project comes together, so whenever there's a problem, you have to figure out if it's a mechanical, electrical, or software problem, only to find out that it was all of them. I believe this is what Stuff Made Here calls integration hell, which is just as bad as the other integration hell. I decided to write my code in the Arduino IDE because I'm familiar with it, although there are a couple other options for the ESP. First, I set up all the pins and define the variables up here. Then we go into the loop, which repeats every millisecond. First, we read in the values of the glove and the potentiometers so we know where the motors are and where we want them to be. Here we have the code for the forearm sensor, which switches the hand between the different preset hand grips. To control the motors, we use a pre-ID controller, which stands for proportional, integral, and derivative, although I'm only using the P&D terms here. Basically, the way this works is the proportional term determines how far away we are from our target and adds that to our signal. So if we're really far away from where we want to be, we give the motor more power. The derivative term looks at how fast we're approaching our target. So if we're moving to the goal very fast, we want to slow down so we don't overshoot and start oscillating. The integral part looks at the error over time and tries to remove long state errors, but I left this out because it was causing problems and the controller works fine without it in this situation. So that pretty much sums up all the technical stuff. There's a couple of things that I'd like to change, but at some point I had to say this is good enough, or I'd simply never finish.
The one thing that I like to say is that if at first you don't succeed, reduce your expectations until you're a success.
Overall, I'm pretty pleased with it, at least enough so to make this my first video. I think it completes all my basic requirements, most importantly being that it actually works. The final hand weighs in at 393 grams, which is 20% less than my goal, and perhaps most surprisingly, I actually came in under budget. I did spend a bunch of money on wild goose chases, but all the stuff actually on the final robot adds up to about $100. That wraps up this video. Thank you guys for watching. I'll definitely make a V2 at some point, but in the meantime, let me know in the comments what you thought and what you'd like to see me make next.